All right, video number 2. So now we're going to practice solving equations and isolating variables. The reason why we're doing this comes up a little bit in this unit. We'll need it for some stuff at the end, but then we're going to be doing a lot of this in later units. So it's going to be an advantage to do it now, I think. So it's algebra, right? So you guys have done some of these things in the past. So we're just going to solve for x here, right? So something like this. We've got x minus 13 is equal to 5. Okay, so the main goal here when I'm looking at this is I want to get x on its own, right? So on its own, I mean I want x to be on the only thing on one side of the equation, right? So just to kind of remind you when we're doing algebra here, you've got the left side of the equation and you've got the right side of the equation. And you can move things around. You can move things from the left to the right, just by doing the opposite operation or the inverse operation. All right, so what we're going to do, I want x on its own, right? I want it to be the only thing on the left side of the equation. So what that means is I want to get rid of this 13, right? This negative 13 or this minus 13. All right, so here's what the rule is. You always want to do the opposite of what's being done, right? So if I've got x minus 13, well, what's the opposite of subtracting? Well, you might say adding, right? Like that seems like the opposite, right? Okay, so that's what we want to do. So what we're going to do is we are going to add 13 to both sides, right? So we're going to add 13. But here, I just want to stop for a second. Would it make sense if I just added 13 to this equation? Well, no, because you can't just like randomly add 13. That just changes everything. That changes the whole equation, right? But if I add 13 to both sides of the equation, I didn't actually change anything. It ends up being exactly the same equation. So I'm going to add 13 to both sides. And the reason why I'm doing this is because if you look up here, right, I had negative 13 plus 13. Well, what is negative 13 plus 13? So you're at negative 13 and then you move 13 to the right. Where are you at? Well, you're at 0, right? That would be equal to 0. So they really cancel each other out. They're gone. So in the end here now, I've just got x, right? That I've just got this left there is equal to then 5 plus 13. So then actually just add those things. 5 plus 13, we get x is equal to 18. And that's it. Okay? So I'm going to go through, and that's the gist of the whole thing. We just, we add more steps, right? This was only a one-step solving problem. So we're just going to just add a few more. All right, so I'm going to go through a few of these now. So that was, adding. Okay, let's do 3. I'm going to let you guys do 2, right? So you'll do 2. What's the opposite of adding? You probably subtract everything. Okay, moving on to 3. Okay, we want x on its own. We want x to be the only side, or the only thing on this side of the equation. Well, how do I get x on its own? Well, I need to get rid of this 5. Just so you gotta ask yourself, what is that 5 doing there right now? Like the 5 and the x? Well, the 5 is being multiplied by the x. That's what it means when they're written beside each other, right? If you've got 5 written beside an x, that really means 5 times x. All right, so what's the opposite of multiplying? It's dividing, right? Divide by 5. So remember, when you write over, that means divide. So 5 divided by 5, well, and then I'm going to do the exact same on the other side. And I just want to remind you, I want you to figure out, why we divided by 5 here. What is 5 divided by 5? Well, it's 1, right? 5 divided by 5 is 1. So really, when I go 5 divided by 5, I'm going to do that cancel sign. But what that really was, 5 divided by 5 would be like 1 times x, which is equal to, and then 25 divided by 5 is 5, right? So 1x, well, I don't need to write 1 times x. That's just x. So x is equal to 5. So you guys, when you went 5 divided by 5 there, you didn't have to write 1x. I'm just kind of explaining why that worked out for us, right? Okay, hopefully that makes sense. Okay, number 4. All right, so first thing I'm going to do, this is kind of the way that, like, you write some equation on a computer. It's not the best way to see it written. So very first thing, if you guys see this, like, line like this, like the dash that means divide, I'm going to rewrite that right off the bat as x over 2 is equal to 17. Okay, so x over 2 is equal to 17. Okay, now, I need x on its own, right? I need that x on its own. So what I'm going to do, I'm going to get rid of this 2. All right, how do I get rid of a 2 that I'm dividing by, right? I'm dividing by a 2. Okay, well, you multiply by 2. And when I say multiply by 2, really what I mean is I'm going to multiply this term up here, right? The whole thing by 2. When I say multiply by 2, that means I'm putting a 2 up in the numerator. I'm putting a 2 up in the top, right? So this is really like a 2 up there. But I can't just multiply one side of the equation by 2. I also have to multiply the other side by 2. Okay? So just again, looking at what we have over here, I've got 2 over 2. Well, what is 2 over 2? It's 1. They cancel each other out, right? So in the end, we're just left with x is equal to, so 17 times 2, so 34. All right. Okay. Now, number 5, we've got a 2-step problem, right? So before I only had one problem in these ones, right? I only had a 5 to get rid of, or I only had like the 2 to get rid of. Okay, so in this one, I've got 2 things to get rid of, right? I need x on its own, so I gotta get rid of this 11, and I gotta get rid of this 3. And now the question is, which one do I get rid of first? Well, I always use like this onion analogy where if I want to get to the x, right, you want to peel off all the layers of the onion. Well, so you got to go to the outside layers and then work your way to the inside. Well, this 3 is like attached to the x, right? That's like close to the x. That's like the inside of my onion. This 11 is just kind of like loosely attached. It's not really attached to my x at all, right? It's on the outside. So like this thing is the outside of my onion. That's got to be the first thing to go. Hopefully that makes sense. I'll explain more too when I get back. All right, so I need to get rid of this 11 first, this negative 11 or this minus 11. How do I get rid of something that's negative 11 or minus 11? What's the opposite of that? Well, it's plus. So I'm going to add 11, and whatever I do to one side, I got to do to the other, right? Okay, so that's step number 1. So remember, negative 11 plus 11, those cancel. Those are gone now, right? And then in math, we work our way down, right? I'm not going to work to the right or work to the left. I'm going to work my way down from here. So now what do I have left? Well, I've got 3x, and remember, this is gone, so it's just 3x, and that's equal to, and now I just need to go 28 plus 11. So that's going to be 39. Okay, so now this one looks pretty much like, I just want to show you an example when we did. It looks pretty much like when we did this one, right? So it's going to be the same thing, right? I've got 3 times x. When they're written beside each other, it means times, right? What's the opposite of times or multiply? It's divide. So we're going to divide both sides by 3. So divide by 3, divide by 3. Okay, so I'm left with x is equal to 39 divided by 3 is 13. All right, let's see what we got next here. Number 6 is over here. All right, so I'm going to leave that one for you because it's going to be very similar. The only thing here on 6 that I'll kind of give you a hand with, if you've got 5, like this 5 sitting out front here, this is really like plus 5, right? This, like, you can think about like positive 5. So if I wanted to get rid of this guy first, what I'd be doing is I'd be going minus 5, right? Minus 5 first. So I'd go subtract 5, subtract 5. Okay, so that'll be your hint, and I'll let you guys finish 6 there. Okay, number 7 though, I should probably do 7. Okay. All right, so 7. So we've got, I'm going to write this out again, just maybe up here. So I've got negative x plus 7 is equal to 23. All right. So I need x on its own, right? And with this question, there's a couple of ways to do this, right? I think we're going to stick to the way we've been doing. All right, so what would I get rid of first with my onion here? Well, the very first thing I'm going to get rid of would be our 7, right? So what I'm going to do is I'm going to subtract 7 from both sides, so minus 7, minus 7. Those would cancel. So we've got negative x is equal to, so it's equal to 16, right? All right, so now here's the problem I'm facing right now, though. Seems like I'm pretty close. I've got just like, you know, x on its own and 16 over there, right? But the only thing is this negative out front. I've got a negative sitting out front there right now. Well, here's how we're going to get rid of that negative. All right, so bear with me. We're going to get rid of that negative by calling this is when there's negative out front of this x, you could really think of that as like negative 1 times x, right? There's really like that was terrible. There's really like a negative 1 sitting out front. Let's see if I can write this again. There's really like negative 1 times x, right? Times x. Okay, how do I get rid of this negative 1 that I'm multiplying by x? Well, I'm going to divide by negative 1. Okay, so divide by negative 1. So those would cancel, and I'm also going to divide the other side by negative 1. All right, so I'm on the left side, I'm left with x is equal to, and then what is 16 divided by negative 1? Well, what is 16 divided by 1? Well, that's just 16. But what do you get if you go a positive divided by a negative? You get a negative, right? So this x is equal to negative 16. All right. All right, I think I should do this one too. It's the last one I'm going to do with you. Okay, so we're going to say, I'm going to rewrite this because I don't really like the way this is written. This is 2 over 3 and then times x plus 1, it's equal to 0. Okay, so we'd write it more like that. Now, what would I get rid of first? Well, the 2 and the 3 are like, they're attached to the x, right? They're pretty much attached to that x. They're like the inside of my onion. This plus 1, that's easier. That's got to go first, right? I'm going to get rid of that plus 1. That's the outside of my onion. So to get rid of it, I'm going to subtract 1 from both sides. So minus 1, minus 1. So I'm left with, I'll give myself much room here, 2x, or 2 over 3 times x, which is the same thing as 2x over 3, which is equal to negative 1. All right, so now, how do we get rid of this? This here with 2 over 3 times x, that's the same thing. It's just like 2 separate problems, right? Remember this one? This was like x over 2, and this one was like 5x. We just kind of have to do both now, right? I'll show you what I mean. I could get rid of the 2 or the 3 first. It doesn't really matter which one I get rid of. I usually get rid of the denominator one first. And if I'm looking at this 3 here, right in the bottom, if I want to get rid of that 3 that I'm dividing by right now, what's the opposite of dividing? It's multiplying, right? So I'm going to multiply both sides by 3. Okay? Both sides. I'm going to multiply this way, 3. And I hate this because I'm running out of room, but let's write it. Let's keep going up here. You probably have more room than me. Okay, so what we have left here, right? I got rid of that 3. So I just have 2x is equal to, and then what was negative 1 times 3? Negative 1 times 3 is negative 3. All right, so we're close. We just got one more step to do. How do I get rid of this 2 how do I get rid of this 2 that I'm multiplying? I'm going to divide. I'm going to divide both sides by 2. So divide by 2, divide by 2. And in the end, x is equal to negative 3 over 2. All right, so I'm going to leave 9 for you guys. And maybe I'll give you like a little bit of a hint on this one. I'm going to rewrite it. 1 minus, and then it's in brackets, but it doesn't really need to be in brackets the way this is. I'm not even going to write it in brackets. I'm going to rewrite this as minus x over 4 and it's equal to negative 15. All right, so the hint that maybe I should do this one with you. Yeah, let's do this one together. Okay, what we're gonna do with this negative out front here, you could handle it two ways. I'll kind of show you what. This is really like a plus one, right? So this plus one, we could subtract one from both sides and bring it over here, right? That's what we've been doing. That was like the way that we were doing it before. That would work. We could do that. But the other way I'm going to show you that might be a little bit simpler for this one is I kind of like it when the x term, when this term is just positive, right? I'd rather that not be negative x to the 4. It's just a little bit easier to deal with. So what I'm going to do is I'm going to move that term. Here, sorry, I'm going to rewrite this. 1 minus x over 4. But I'm going to move this term. And the way I'm going to move this term that I'm subtracting right now is I'm going to add the whole thing. I'm going to go plus x over 4. Are you guys okay if by saying negative x over 4 plus x over 4 would just be equal to 0? Well, just if you're not, just think about it for a second. I know there's like over 4 and it's all like looks confusing, but if you've got anything where there's the negative version of it and the positive version of it, then they're going to equal 0, right? The whole thing would just be 0. So they would cancel. That one and that one would be gone. But I also have to add x over 4 on this side. Yeah? Hopefully that made sense. All right, so if I clean this up, right? Just got my equal sign in the middle. I've still got 1 on this side, so I've got 1 is equal to negative 15 plus x over 4. And the reason why I did that is because now this is positive. It just made it a little bit nicer. I don't got to deal with that negative later. Yeah? All right, so now what I'm going to do is I'm going to add 15 to both sides, because that's like the outside of my onion, right? So add 15, add 15. So I get 1 plus 15 is 16, is equal to x over 4. All right, so now we've seen ones like this, right? Even though x is on, I want you to notice though, x is on the right side of the equation. That doesn't matter. Who cares? Like, it doesn't matter what side x is on. It just has to be on its own on one of the sides. Yeah. Okay. So this 4 is on the bottom right now. I'm going to multiply both sides by 4. Multiply by 4. Okay. So we get x is equal to, because I've just got x on its own over here now. X is equal to 4 times 16. So 2 times 16 is 32. So it's going to be 64. All right. Hopefully that made a little bit of sense. Yeah. We'll go over that a bunch more, though, too. We're going to practice this stuff a lot. All right. So you guys are going to be responsible for finishing the rest of these questions. And also, guys, I kind of messed up. I want you to do those ones. And I also want you guys to go back and do these ones on your own, too. So these will be, you guys will be responsible for. And yeah, I'm going to show you how to do some of these in a minute too. So, sorry, I'm kind of jumping all over the map here. Okay, now, in these questions, it's going to be, it's a lot of the same concepts as before. Last time we were actually solving, but this time we've got 2 variables. Okay? What we're going to do for each of these, and this really relates to what we're doing in this unit, it says isolate y in each of the following equations. Isolate means I want just y on its own. All right, so right now, if I want y on its own, this x is my problem. I need to get that x out of there. I need that x to be on this side. All right, so how do we get rid of this x that is a positive right now, right? That's a positive x. Well, we subtract x, right? We'd subtract x from both sides, right? We'd have to subtract it from both sides. So those cancel, and I'd have just y now, just y is equal to 3, and then minus x. So we subtract it from both sides. And that's it. That would be an equation for a line. That's why we're doing this, is because this is how that would look. All right. So now, let's do number 2. Number 2, we're going to do the same little type of thing that we did last time. Where, okay, I want y on its own, right? That's the goal here. it doesn't matter which side. Well, I could get this 7 out of here, right? I could go minus 7, and I could go minus x to get rid of those. But then I'd still be left with a negative y on this side. That'd be okay. What you would actually do is you could divide everything by -1, and it would work out fine. But I know an easier way. We're gonna do just, it's like a one-step thing if we do it this way. I'm just gonna take this y, and I'm gonna move it to this side. Okay, so the way we're going to move this y over is we are going to add it to both sides, right? Because right now it's negative y, so I'm going to go plus y, right? So plus y, those would cancel, and if I go plus y on this side, then we're just left with x plus 7, right? Those are the two things I had left over here, is equal to positive y or just y. And that's fine. Like, I know y is on the right side now, but that's good. It doesn't matter which side you isolate it on. All right, I'm gonna let you guys do 3. My little suggestion here is I would probably move this y to the left, and then I'd probably move this x to the right, if it was me. But you'll start to notice there's a few ways to do these things. Okay, I'm gonna let you guys do number 4 as well. So I get rid of this 2. And then I get rid of the 7. So just remember, do the inverse operation. So this is really like plus 2, right? So what would you do? This is really like times 7 times y. So what would you do? Okay, I'll let you do 5 as well. Yeah, you know what? I think we've kind of like covered all the skills you need. I think it's time for you guys to work on these now. Solve for y. So I'll just kind of go over this one. These are actually a little bit... some of them are a little bit simpler. What's happening here? What's going on? Go away. One sec. Okay, it just disappeared for some reason. Okay. All right, so on this one, it says solve for y in each equation below when x is equal to 2. All right, so what this means, when x is equal to 2, that means that this x right here shouldn't be an x anymore. It means that we should go y is equal to, and then instead of an x, I'm going to make it a 2. So it's going to be 2 minus 3. One thing that I do quite a lot, especially when they get harder, is I put it in brackets like this, right? So everywhere that there was an x, I put, in brackets like what number they want us to put in. Okay? So let's... So then, yeah, I gotta finish that. So y is equal to, so what is 2 minus 3? Well, you're at 2, and then you go 3 to the left. You're now at -1. All right, I'm going to do 6, too, while we're at this. The other ones are on the other page. But this one says I need to figure out y, right? Well, the way I'm going to do that is I'm going to get y on its own first, and then I'm going to put 2 in for x. All right, so... I need y on its own. What I'm going to do is I'm going to bring this -4y. Well, there's 2 ways to do it. I could do it either one. I could bring the -4y to the right side, or yeah, let's do that. So I'm going to bring -4y to the right. So I'm going to add 4y to both sides. So plus 4y, plus 4y. Those cancel. And I've got 8 is equal to x plus 4y. So now I need y on its own. How do I get rid of, what do I do next? I got to get rid of this x. So minus x, so I get 8 minus x is equal to 4y. And then the next step here, guys, is we are going to divide everything by 4. So I'm going to divide by 4, and that means I need to divide this by 4 and this by 4. So I end up with 8 divided by 4 is 2, minus x over 4, which is equal to y. Now, I need to go 2 minus, instead of an x, I'm going to put a 2 in there. So 2 over 4 is equal to y. So this is really 2 minus a half, right? 2 over 4 is a half. Okay, extend this a little bit. And now... oh, I got fractions, right? It's really 2 over 1, so I'm going to call that 4 over 2 minus 1 over 2, which is equal to y. So this is really 4 minus 1 is 3 over 2 is equal to y. All right, that was a tougher one. Okay, so I'm going to let you guys finish the rest of those. That is your homework. And we'll be working a bit more on this in class as well. So I'm going to leave it there.